Good day, everyone. What we're going to be discussing today is the Electrical Safety Analyser from Fluke, the 620 Safety Analyzer. Starting off at the back of the unit is where our power connects and where our USB cables connect. On top of the unit, you'll see this funny connector here. Unfortunately, when we order these units, the South African 3-prong plug is not part of the ordering list. Thus, you will be required to make a little adapter similar to this with a South African plug so that you can connect this in and then have the ability to plug in your South African plug on the side here. So that is our South African plug. Then the unit at the back also is our power switch. So the moment we switch the unit on, the first thing the unit does when you switch it on is it actually tests the power, the integrity of the power source which is plugged into, the AC source. And if there's a problem with your, let's say the earth for instance, on your power plug, the unit will come up with a fault telling you that it cannot find an earth. The same error will also come up when you work in an environment where, like in a hospital's theatre or an ICU, where you have a isolated power supply, or a, what's the other word they use for that, isolock. Because you're not using a real earth, you're using a center tap transformer, a floating earth. So it is always recommended to plug this unit into a power source where you have a 0 earth and a 220 live. Okay. Once the unit is switched on and it's happy with itself, it's passed the self-test. It comes up, it tells you at what standard it is set at the moment. Now this standard will set the limits of the measurements, whether it passes or fails according to the set limits of these standards. So we're first going to start off with the setup button right at the bottom here. By pressing that button, you can see we come up with, under function 1, we've got the instrument. If I enter that, we have the resistance measurement, 2-wire. If I press function 1 again, it changes to 4-wire. Now, looking at up here, we have a 2-wire connection and we have our 4-wire, meaning we're using all 4 of them. On some equipment, you will be required to do a 4-wire resistance, even though that is very, very seldomly. Most units only requires one earth cable to be plugged in from here and connected, the other side of the cable connected to the protective earth of your instrument. If it happens that you have to make use of a 4-wire system, what you'll have is you'll have a second cable plugged in on that side, and then also going to a protective earth pin somewhere on the applied unit. Okay. So for now, let's just remove that 4-wire unit. The next on the list is our test current. So when we are testing the earth resistance of the unit, we can either do it with a high or a low test current. Low test current is up to 25 milliamps, which is applied to the unit. A high test current is up to 20 amps being applied to the unit. Polarity delays. The function of this machine is to actually test if there are any problems in your AC power source, meaning live and neutrals may be swapped around, maybe the earth is disconnected or any of those things. Now, in order for this machine to do that, it will keep on switching between different problem configurations. So this machine will be disconnecting earth, it will be reconnecting earth, it will be disconnecting the live, swapping the live and neutrals around, etc. And this is where we set the time between each of those configuration changes. So you can increase it up to 5 seconds delay between the switches, or 1 second, depending on what your service manual recommends. Okay, we go back. Next, function 2 is our display, where we set the contrast. Again, These up and down arrows refers to these up and down arrows on the side here, where you can then change the contrast of the unit. Done. Then function 3 is our sound, where we can switch the beeper on and off, and we can change the volume of the unit. Done. And then if we go to more, we can find here the instrument information, which will tell me the last calibration date, the serial number, and the software versions of the unit. Back. Next up on our list is the standards button. If I go into the standards button, you'll see it comes up here with EN62535, which is the generally used standard. But by using the up and down arrows, you can see you can go through all the various ones, 60601, etc. So depending on your recommendation on your service manual, you'll select the correct standard from here. Let's just go back to my regular standard and press the select button. The next function we have is our point-to-point measurement. Now, point-to-point is something which we tend not to recommend. What that is you can use this unit as a multimeter, a normal multimeter, to measure voltage, ohms, and current. But please pay attention to what is written on the side here. There's a maximum of 300 volts, a maximum of 2 ohms, and a maximum of 10 milliamps. If you exceed these settings, you might be damaging your unit. So therefore, we recommend rather use a normal multimeter to do these tests with, but the function is available as long as you stay within those limits displayed there. Then we go to our ECG wave here, which then will give us a ECG simulator. Waveform, you see it's on ECG complex. If we press function 1, the change becomes, the function becomes changeable. So with the up and down arrows, we can change to triangular, sine wave, square wave, pulse wave, and back to ECG complex. On this particular unit, there are not a selection of arrhythmias or any of those. There's just a normal sinus ECG wave. What I'd like to point out, though, as well is, please remember this has big transformers inside, causing a lot of noise, unfortunately. So do not use these this ECG simulator for diagnostic purposes. Only use it in order to supply a signal to say, okay, there's a signal, okay, it works. Do not use it to measure the signal width or height or any of those type of things. For that, you use a normal signals generator. There's your rate again for your complex and the exit button. Okay, next on our list is the microamps button. This is where we measure leakage currents. Now you can either, the options available is you can do a direct equipment leakage current, a differential leakage current, or an alternative equipment leakage current. So, and then on top here you'll see this bar with the dots. That corresponds to the applied parts bar on top here. Now, the way we do this is you first select which one measurement it is you want to do, direct, differential, or alternative. So by selecting direct equipment, after that, I need to select which one of these pins I want to use for the measurements. So by going to the More button, I get into the Select Applied Parts Group testing selection area. So now by using these arrows, you can see now it changes to different configurations, and there's single ones. So if I only want to do is, let's say we've got a 3-lead ECG we want to do. So then I can select the first 3. I can then apply my cables to the first 3, as now, and I can say select, and we are ready now to do the direct applied parts, and by pressing the test button, it says push test to apply the voltage. I press test, it's applying the voltage, and we just wait for the measurement, and there we can see there's our measurement made on these 3 pins. Okay. The same applies for alternative applied parts. Then you can do the same there. We go back. So whichever you use, either differential, alternative, remember to go differential, go to more, and select which one of these pins you want to use. That is your leakage current. Next on our list is the mega ohm button. This is where we measure the resistance, the impedance isolation resistance. Sorry, that's the right word for that. First we have mains on protective earth, applied parts, these ones on protective earth. If we say protective earth, we're referring to this pin here going and being applied to the protective earth of your device. Mains on applied parts, meaning measured from the mains to the applied parts, which might be an ECG cable, SPO2 cable, or whatever applied parts it might be. And more, we've got mains on a not connected earth situation, and applied parts on not connected earth. And then we've got a changing voltage. You'll see that here we are testing at 500 volts DC. Some units might require you to bring that down to 250 volts. So that is where you use the change voltage button, is to bring the voltage down. Okay, let's go back. Okay, so that is our insulation resistance measurement. The next is our current. For this, I just want to switch on my unit there. Okay, this is just straightforward equipment current. So whatever is plugged in here and switched on, it will tell you how much current that machine is drawing. Okay. Next button is voltage, which is now our main voltage. And from here I can select whether it's a live to neutral measurement. Is it a neutral to earth? If I press that button, I'll get the neutral to earth measurement, or a live to earth. And those are the measurements we can do from here. Exit. And then we go to ohms. Now, this is our protective earth resistance. It's not the isolation earth resistance. This is protective earth. So this is where you can see we are set on 4-wire here. If you want to change that 4-wire, remember, go to Setup again. Go to Instrument. And under Resistance, we change it to 2-wire. And go back to your ohms again. So again, this will be connected to your protective earth. But what we need to do firstly is this whole cable has a resistance between this machine and the device under test. So we need to know what the resistance of this cable is so that we can subtract it from the value we get. So what needs to happen first is the other end of this cable needs to be plugged into the null point, and we need to say 0 lead. So once we, come on, 0 lead, press test button, it applies a current, and it tells me that now it has determined what the value of this cable is, and it will be able to subtract that from the total resistance value measured. Then I can remove this pin, put back my crocodile clip and attach it to the machine's protective earth. Once done so, by just pressing the test button, the machine will apply the current and give me a value. Now when it says NC, meaning not connected, that normally happens when you have a type 2 unit, meaning it has an external power supply, there's no earth pin connected on the unit, or it's a floating earth.